All right, welcome back, everybody. We started this problem last class, but we're going to go ahead and jump in and catch ourselves back up. So we're going to graph this, and we're going to do this one problem. It's going to feel kind of clunky as we go through it. Then we'll generalize like, hey, here's all the steps that we're going to follow like every single time, and then we're going to make these graphs seem easy by comparison. So checking it out, I erased it, which I wish I hadn't. What's the first thing I had written here? Factor and simplify? Okay, so I'm just going to say simplify. All right, so check it out. We had factorizations happening. So I'm trying to think of factors of negative 18 that add up to 7 in my head. So I know it's 9 and negative 2. I don't remember exactly how it goes, but we'll check it out because I can't group in my head. So 3x squared, and it was 9 and negative 2. So I'm going to say plus 9x plus a negative 2x, minus 6. And then I'm factoring this just as we go, right? Can you guys tell what I've done? If you can't tell, and I'm going to undo this line, but this is what I've done, and I can do this much in my head. That's what I've done, and I just rewrote it. Okay, so let's see down here. This one's even easier. Factors of 3 that add to 4. I know this is x plus 3 and x, lost my train of thought, plus 1. Looks right to me. Okay, here we go. One more step to simplify this. What would you take out of this group? Okay, if we factor out a 3x, it would leave behind an x plus 3. So I'm trying to save a little bit of writing here because you guys all have this, right? Theoretically. X plus 3 is one of them, and I know a 3x came out, and it better be a negative 2. So it looks like 3x minus 2 is our other one. Okay. Over x plus 3 times x plus 1. Can somebody confirm that I haven't made a mistake? Because I don't have anything in front of me that has to do with Precalc. We're good? Cool. Thank you for that. Awesome. Did we do anything more than this? Found asymptotes? Okay. Now, when I looked at it, I remember seeing that this happens. Do we have a comment next to that anywhere? And I'm going to do that a little bit lighter. Did we ever make a comment about these ones? There's a hole. Okay. We will see. We won't really be able to see it because points from geometry, if you recall, infinite, like there's no size to them. So as small as you want it to be, we obviously have to put a point on our paper to see it, but there it is. Okay. Which means our real function in most simplified form then that we're graphing is 3x minus 2 and over, x plus 1. Cool. So on B, and I'm going to try to show it all on the same line, we said asymptotes. So I'm going to be lazy with my writing. If I say VA, what is it representing? Vertical asymptote. And how about, horizontal asymptotes. Cool. Okay. Pretty much every single time, these are going to follow the same sort of scheme to approach these. So vertical asymptotes, just remind me, they happen at the zeros of what? The denominator. So as we get really close to 0, whatever's in the numerator, remember, it blows up to either positive or negative infinity. So looking at our most simplified form, are there any values of x after this, after we've simplified, that make me divide by 0? Good. I hear confidently and loudly -1. Awesome. How about horizontals, and how do we check? Rafa, what is the degree of the numerator and denominator for our most simplified version of f? Not 1. Oh, it is 1. I'm sorry. I was looking at the original. You're right. I'm wrong. Cool. So if they're both the same, it's just a ratio of their somethings. Leading coefficients. So I do see there is a horizontal asymptote at y equals, what's that ratio give me? 3 over 1 is 3. And this is where we left off? Cool. All right. So right now, just think about where we're at. All we know is on our graph, there's some lines that, vertical ones we never touch. The horizontal ones we get really close to as we get to infinity. That's what we know. Are there, like, I'm going to sketch this out, and don't do it yet. We'll say if it's gray, pencil away. I'm going to steal that one. Was that Fern? Cool. All right. So right now, just so we can think about it, if we're trying to graph this, and I'm going to sketch this really roughly, here's all I know. If that's -1, there's a line here that I never touch. And the line y equals 3 here I can touch, but towards the ends I won't touch it. Do you know where my graph lives yet? Not yet, but we're getting there. Now, just so we can kind of think this out, it could do something like this. Do you guys agree? Okay, it could do something like this, up on both sides. It could do something like this, or it could do something like this. Those are the only 4 options that we have. Okay, we need to decide which of these it is. And it turns out there's an easy way to look at this. If one of them wind up going downward, do you agree that we're going to cross the x-intercept? As long as one of them does. Okay, which means if we want a better idea, man, is there a way to find x-intercepts that we've talked about in here? Have we ever talked about how to find the x-intercepts of a function? Like every day for the past 4 to 6 weeks, I would argue, we've been looking at that same question. Now, bigger extension of it though. Talk with your neighbors. Like actually talk. I want to hear words and communication of ideas through vocalization. When is a fraction 0? It's going to take like 5 seconds. This fraction must be 0 sometime. When would it be? That's the only question I have. 20 seconds. Get loud, talkative. When is a fraction equal to 0 is the question. Ooh, careful. If x is 0, what's that function? -2/1, right? So I don't quite like that answer. I like that you're giving it. So -1 is, if we plug in -1, we get -5/0. Is that 0? Kalisha, thought? You were looking toward me.
No, I was just listening.
No, you're good. Okay. If I want this fraction, f of x, to be 0, I heard one group say the answer right away. What happens if the denominator is 0? It's undefined and you get an asymptote. Okay, so it can't be there. What happens if you have 0 over anything? 0. So if I want to know where the zeros of this function are, the x-intercepts, I just need to know when the numerator is 0. Would you agree with that? So check it out. We're going to say on step C, and we'll like get all this in a nice, concise 8-step process. Find roots. Now, I'm not going to write it here because I'll write it in a minute, but it's when the numerator is 0. And if you need justification of that, anytime you're solving by factoring, you set the whole equation equal to what? 0, and check it out. This will logic out. We'll get the same thing. If I set the whole function equal to 0, and you don't love fractions, how do you bust this fraction? What can I multiply both sides by? So if I do it here, and I do it here, let's see, I'll do the right side. And what's the left side? 0x plus 0 is still just 0. Notice, it's ultimately just a numerator, right? Like, you don't just have to take my word for it. We can see it. What value of x does this happen at? X, we add a 2 and divide by 3. Okay. Right now, I'm going to argue that I have enough to sketch this function. Okay. Let's check it out. Part D, and this is going to drive me crazy. Are your notes back and forth and wonky like mine, or did you write them normal? Yours probably just go sequentially, like straight down. Okay. So in yours then, part D, we're going to sketch. Now, we're going to use all this information, and because I'm sketching, I'm not going to get any extra points out, but let's think it out. I need to see which x values, based on everything that we've done, are there any x values that I for sure need to be able to see on my graph? I need to see 2/3, that's my x-intercept, and I need to see -1, that's my asymptote. Now, I'll usually go a bit past that, and just so it's the same as yours, I'm going to go ahead and black out my graph paper. So that you see, we don't have to cheat with the grid. Hate that it's not square. That's going to keep bugging me. But all right. So check it out. Here's my Y scale. I have no idea how big it is. Here's my X scale. Now, I know that I need to go to -1 to see it, so I might just pick a graph like this. Okay. Does my scale have to be perfect? No, I don't expect you guys to use a protractor every time. But let's just think this out. If I have to be able to see 2/3, maybe I go 1. 2. Why am I doing 3 little ticks like that? Yeah, so I can see the thirds easily enough. Now, if I know just that right off the bat, I'm going to put a root at 2/3. And it's going to be like right there. That's my x-intercept. Everybody still on board? Okay, we should decide on a color. On yours, you should dash asymptotes. That's what I'd like you to do. I can't draw a dash here. What color do you want to commit to just being asymptotes forever and always? Purple? Okay, so I'll label those X and Y. And let's get this lovely, we'll use dark purple. So I know there's a vertical asymptote at, what value was it? -1. Okay, so we'll say there's -1 right there. And I'm going to draw a purple asymptote through it. I'm going to try to draw a purple asymptote. Boom, that's actually pretty good. Cool. I would use dashed lines. And if you guys are going to take the time, I guess I can take the time because it's way easier for me. Cool. Do I ever touch that line? No, can't touch it. Never allowed to. Any other asymptotes that I should draw? Y equals 3. Now, because I'm not actually graphing it, I'm just sketching. If I say, nope. If I say, yep, that's 3, would you believe it? Yeah, you have no reason not to. Dark purple, here we go. Okay, harder question. Can I cross this one? Can I cross a horizontal asymptote? Absolutely you can. The only thing that they tell us about is what's going on at the function at the end. All right. You guys ready for this big connection here? Here's my challenge for you. Talk with your neighbors. We have everything that we need. You can graph this. It's going to be a rough sketch, but with only 1 point, and you might get 2 if you really want it, but without doing a table or anything like that, talk with your neighbors and logic through the graph. Cool. I'm going to give you like 2 minutes. Try something. Be okay with being wrong. If you don't have a pencil, I can borrow you one. I wouldn't draw it in pen. Go ahead and try a light graph. Talk it out with your neighbors. No more points allowed. Cool. Kind of gave you an intentionally tough option here. Now, right off the bat, I am certain, guaranteed certain, that I know half of this graph right off the bat. This point is a what? It's a root, a solution, a 0. Give me the last word. An x-intercept, which means I know that my graph touches that point. Everybody on board with that? Okay. If it touches that point, there's only 2 options. I guess there's probably more than 2, but I want to talk about the 2 that I see and that I imagine you see as well. Oh my goodness gracious. Kaboom. All right. It touches this. Now, if you wanted to, and I asked you guys not to, but we can probably think out a couple more points. Can you plug in 0 on this pretty easily? What's f of 0? -2/1 is just -2, right? So without having to write it down, and I know that's kind of cheating, I'm going to eyeball that there's my y-intercept. The second I do that, even if I hadn't done it, I know for a fact that this graph must touch the intercept right here. Okay, now, bigger question. Don't sketch this part, okay? We'll go back to gray for just a moment. There are graphs where I know they touch and turn around. Somebody give me a justification to say this graph does not do this. There's a couple options that I'm cool with. I liked yours, Huggins. Can you tell me what you said when I asked you that question?
There's no second root.
there would be a second root if it was going to touch the axis again, right? So I know it can't touch the axis. That is completely out. If it can't dip back below the axis, then it must always stay above it. Everybody cool with that? Now, beyond that, we don't get the full story here, but I bet our assumption is going to be good. This thing is probably going to get close to it like this and start to level out. Now, I want to highlight here what we don't know for sure. Could it do something weird like this? It could. I would bet American dollars that it probably does something like that. Okay, that's half the graph. These are hyperbola, is what we refer to these as. Just so you know, I'm kind of crazy with units and stuff in physics. I'm less crazy in math, maybe. I don't know. I will take points if it looks like your function touches your vertical asymptote. Make it real clear that this thing bombs down and never actually touches. And that was a comment that I was going to make. Yours is fine. But be careful, because I will take points just for sloppy handwriting there. Be careful with it. All right. Now, the other side of it, we have two options. It's either option A or B. Talk with your neighbors, 20 seconds. I can rule out one of them without knowing any more points.
What?
Why isn't it A is a new question. Why can't it be A? Louder?
No, it's B.
Sean says we would have found another route. If I knew, if this thing was going to cross the x-axis again, we would have found it with our zeros. Like, those are the only places it'll ever touch the x-axis. It never touches again. This one's out. It's not allowed to. Okay. Which means the other option, with just a brief sketch, I don't know anywhere where, like, as far as values, but I bet it's something like this. Now, this is a sketch. We needed 1 point to make this work. Do you think it's pretty close to what it actually looks like?
Can we see?
Yeah, let's check it out. Now, notice though, just so that you guys are aware, because when I go on Desmos, the scale is typically set to be the same in the X and the same in Y. But let's see if we get the same shape here. So, human population reached 8 billion in 2022, just so you guys know, a little fun fact for you. What do you think it'll be at in 2050? It was 1 billion in 1804. It was 8 billion in 2022. By 2050. Your first guess was almost like perfect. 9.8 is what the current prediction is. Cool. Okay, let's check it out. F of x equals. Can somebody read me the original function?
3x squared plus 7x minus 6 divided by x squared plus 4x plus 3.
Okay. Does that look like the graph we just made? Now, there's one little piece that we're going to add. And anybody in here take note and pen? Cool. So you're going to need an eraser, or you're going to have a bold mark. Because there's one other thing that we've just disregarded this whole time. The very first thing that we did when we simplified, something fell out, right? The whole fell out of this equation. So if we're looking at it, the whole would have happened at which x value? -3. So without a scale, it's hard to see, but -1, -2, -3, roughly. What I'm going to do is I'm going to say, hey, check it out. Here's -3. And I want to make it really clear. My function is broken there. We literally just add a whole. Now, here's something weird that happens. When I go to Desmos, let's see what it looks like. So here's my function. It's all fine and dandy. And I'm going to zoom in. Here's -3. You guys see the hole? Okay, so pretty sure that's still -3. You guys see the hole yet? Now, yep, getting closer, closer, closer. Oh, I didn't do the, yeah, I did. Okay, check it out. Oh, there is a hole there. It doesn't show it because computers are terrible at understanding the infinitely small or infinitesimal stuff. Our hole, whenever we draw it on a graph, needs to be very clear. So open circle for any hole that you might have, something that falls out, and then asymptotes, and you're golden. Everybody cool with that? Okay, so let's refine this little process here. Is that super duper hard? Like, it's kind of lengthy, but the cool thing about it is it's tying together like everything that we've seen. We do a little bit of division, we divide it out, we check degrees, we get the factoring, we get the solving, like we get every single piece of this. So let's check it out. Oh man, we get inequalities next. So cool. All right. Let's get a nice kind of list. So here we go. Looking at it. These, I'm going to call them guidelines just because I don't like having like a strict set of operations. So let's talk about our second main section is putting all this together. Sketching. Can somebody read this to me? And there's a couple different ways you can say it. Who's feeling calm? Ooh, go ahead, Sean. Ooh, f of x in the set of all rationals. The language changes. It doesn't translate like word for word, but this just says sketching functions and the rational functions. Okay. Awesome. Here we go. Step 1. I should have told Huggins he's going to miss like the most important piece here. He gone. Okay. So right off the bat, we're going to let f of x, just like we did before, we're going to let it equal some n of x, so a numerator function, over some denominator. Okay. That's it. Now I'm going to go a little bit more bold here. Okay. Step 1. What's the first thing we did on the previous problem? Factor and simplify, right? Now, we could just write simplify, but factoring is, I can't find the level of boldness that I want. Factor, simplify, and note any, and then I need your guys' guidance. I can either write any wholes or any factors that divide out, and then we'll say which implies a whole. We better do the second one. Any factor, and then I'm going to say in parentheses root that divides out. Whatever divides out is a what? This is the whole. All right, step 1, we've simplified down, we've factored it. You might have to use a PQ list to factor, like those things. Those ideas are still there. Once we have it simplified out, what do? We did what? Okay, we identified asymptotes. Identify asymptotes. Now, I'm not going to write that whole list again right now, but we use one specific idea. Using or comparing what? And I lied. I'm going to write it out just a little bit simpler. Vertical asymptotes. Where do we find them? What about the denominator? Okay, so give me a word or phrase that you're kind of skirting around here. The what's of the denominator? Good. Roots or zeros. I don't know why I drew that line. Zeros, and I don't know how I spelled it last time, but I like to switch, of d of x. Okay. What about horizontal asymptotes? I'm not going to write the whole thing. At y equals, and then I'm just going to say check degrees. And then I'm going to trust that you guys will reference that if the numerator is larger, they're equal, or the denominator is larger. Okay, so now we have all the asymptotes. We have any holes that we've identified. Where do the x-intercepts happen? They're the zeros of something. How do we find the zero of that last function that we graphed. Charles, I haven't called on you today. How did we find the x-intercept on that last example problem that we did? I think it was 2/3 if I recall. The zeros of one part of it. The zeros of the denominator tell us our vertical asymptotes. The zeros of the numerator just give us the zeros of our all of our whole function. So we're just going to say zeros of n of x. Okay. Once you've done this, there's not really a whole lot more to just sketch it. There is one more easy point that we can find without a whole lot of issues. The other point, I included it when we thought about it. The y-intercept can be helpful. Find y-intercept, which is just f of 0. And then once we have all this information, it's just put it all together. Now, how do we draw asymptotes with paper pencil? Dash lines. So without any more, if you want more points, you can find them. But if we're just sketching, I'm just going to say step 5 is just to sketch it. Cool. I want you guys to do one for me. Now, little comment here. I'm going to say sketch. Get a couple or add points as needed. Because from time to time, there might be a weird little thing where we're not sure whether or not it goes up or down. And we're going to see that like right now. Okay. So we factor it. We find the asymptotes, the zeros, the y-intercept, and then we just sketch it. And if there's ever any like ambiguity or something unclear, just plug in one more value. Okay. Y'all ready for this? Nobody wants to bum. Okay. Killing me. I will come back to that. I did it differently than my notes say. So I'll move this function here in a second. Example. I'm going to give you guys a head start. I want you to sketch for me. Cool. F of x, and we'll do 2 if we need, but we'll see how 1 goes first. F of x equals 3x divided by, how big of a PQ list do you guys want to have to make? X squared plus x minus 2 is the denominator. All right. That is on you guys. I'm going to give you a 2-minute, 3-minute head start and awkwardly walk around and look over your shoulders a little bit from here to there. Sweet. We'll resume the video here in a minute. All right, so I'm going to walk in here. Up to now, all I've identified was the asymptotes. Are you guys cool with that part? Zeros of the denominator, right? Now, as I'm looking at the horizontal asymptote, I'm always going to default back to the original that's not simplified, like because nothing fell out of here. There's no holes anywhere. So as I'm looking at this, I see that degree of the denominator is 2 and the degree of the numerator is 1. That tells me that the denominator gets big faster. Like, and the bigger the number, the faster it gets bigger. Meaning that eventually this comes out to what y value? If the degree of the denominator is larger, you're getting a bigger number in the denominator than the numerator. Like, and we can think it out. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000. All those numbers are getting closer to what? I think it's 0, right? Okay. The roots, if we want to find them. What's the numerator of my simplified version? 3 what? It's just 3x, right? And a fraction is 0 when the what is 0? Hey, check it out. My roots happen at x equals 0. Okay. I have almost all the information I need, I believe. Now, what I don't have is a good advice for how do you graph the horizontal asymptote if it's the same as the x-axis. I haven't decided the way that I like to do it, especially if it's on pencil. It's super challenging. I usually just go a slightly different colored line right above the axis. Okay, so let's just see where we're at and if we need any more information. So I'll use this green color for all this. And let's see, I need 0, -2, and +1. I know that much. Okay. So let's see, if we just look at this scale, I'll just do myself a favor, and there's 2, and there's -2, which means those little half ticks are 1 roughly. All right, what's the first thing I'm going to add? Sure, vertical asymptotes. Now notice, I have not picked a scale for y yet. I haven't had to think about it. So let's see, I get a vertical asymptote at -2. And +1. Now, as I'm looking at it, I have a feeling I'm probably going to extend this out a little bit because I want to see on both sides of it. But that's okay. I can deal with that. Okay, there's a horizontal asymptote that I like to do mine like right above there, and I try my best. It's hard on this. I am not going to fault you if you don't add a horizontal asymptote if it's the x-axis. Like, I'm cool with it. Pencils don't work with that. Okay. Well, I only know one thing about it. 1 point, right? The singular point that I can put on this table right now, and love that this happens, is it's right here. And the nice thing about this, and it really drives the idea home, notice it's literally on the horizontal asymptote. I'm allowed to touch it. Okay. Now, there are some bigger ideas that we can start bringing back in just a moment, but I'm going to have to get some extra points, I think. So let's just kind of do stuff. Right off the bat, just so we can discuss, don't draw it. We'll go to this gray color. Could it do this? Kind of. Like, it fits within the asymptote stuff. However, check it out. That root that we found, what was its multiplicity? 1. And somebody remind me, because that's a really fancy word. What is multiplicity? The number of times it shows up. It showed up 1 time, which means I don't think this is an option. Because if a root shows up once, it crosses. Doesn't touch and turn, it just crosses. So, I have 2 options then. It either does this, or it does this. Right? Those are the only possibilities. Now, because I know we're going to the asymptotes, of what we're doing next, I have a suggestion. Step 5 says, sketch it, get extra points if necessary, right? But when we sketched functions before, those ugly polynomials, remember, important stuff happens at places where my function can change from positive to negative. It can only happen at -2, it can happen at 0, and it can happen at 1. Do you guys agree with that? Only place that my function can ever possibly change sign. So let's just plug in a couple values here and see if we can just at least see what the direction is. All right. So I have 4 intervals, -∞ to -2, and I don't even care about the number, I just care about the sign. If you want the number for a better picture, I'm down, like I ain't scared. Pick an easy number, plug into this interval. -3 is what I would choose. Now, I would not plug it in here. But remember, this simplified form is exactly the same. So I'm just going to add a little bit more than we did before. If I plug in a -3, what does the numerator become? And I'm looking at this simplified version is where I'm plugging it in. It's a negative numerator, right? So check it out. In my head, I'm already thinking, okay, it'd be negative over, let's plug in a -3 down here. -3 plus 2 is a negative, times -4 is still a, or now it's a, sorry, negative times a positive makes it negative. And what's a negative over a negative? I know for a fact that my function is positive on this interval, which without any points, it means I know this. It's never going to touch this, and it's going to get really close here without ever touching the axis. It must fit like this. Without getting a value, that's what I know it looks like. Because it's positive everywhere, and it's never going to touch the x-axis again. Does that feel all right? Replicate this process for the other 3 intervals, or 2 intervals if you can justify a time-saving efficiency trick. Struggling? Okay, what's the next value you guys chose? Everybody choose -1. That's a natural choice. Okay, follow-up question. Is this better than if we were just making a big table? Would you rather make a big, like a table and actually calculate out the numbers? If I asked you to graph versus sketch, which one would you use a table with? Graphing is precise, sketching is just rough. Okay, if you plug in a -1, we get a negative numerator over a negative denominator, I believe. Which means it's what here? Positive. Now, x equals 0 was an asymptote or a root? Louder? It's a root, which means multiplicity now kicks in. If it was positive and it had an odd multiplicity, I don't even have to check. What is it here? Negative. It must have crossed. If you want to check 0.5, you could. Let's see, it'd be a positive over a negative. It's a negative. Okay. Multiplicity only works here. Pick a number here. 2. Okay, so if I plug in a 2, let's just check. This becomes 6 over positive times positive. So positive over positive, 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 everywhere positive, right? I know that this graph on this side looks like this because it's positive again. And then all we have to decide is the middle. And I'm not going to be super precise if we're just sketching. I know that between -2 and 0 is positive, right? And then it switched to negative. Not sure what it looks like, but it must change somehow and get close to those asymptotes. I think that this sketch looks pretty realistic. Didn't ever have to put a y value on anywhere, which is pretty awesome. Cool. Check first Desmos real quick. Okay. I bet we're right, but we'll see. Follow-up question is I'm checking Desmos so that you guys don't have to watch me awkwardly type stuff in. I want you guys to find me the domain and the range of this function. Talk it out with your neighbors. Domain and range is my fun extension question. Whoa, get out of there. Oh my god. They're not both reals, just so you know. Are there any x values you can't plug in? Interesting, you're picking the harder question. Domain's always a harder question. Hey, uh-oh. Uh-oh. Time out. We'll be all right. Why? Why are we wrong that this is negative? So if we plug in a -3, we're going to do a little more checking. -3 makes this negative, right? And negative and negative. Uh-oh. Negative over a positive. Should be a negative, right? Man, little tiny mistakes like that. As long as your work is showing, how big of an impact is it going to make on your overall grade for this? No, almost nothing. Like this little tiny mistake, if you do the rest of this big problem well, those things it happened to me unintentionally, just for the record. I expect them to happen to you. Maybe it says Holloway, be a little bit more careful as you're doing these positive and negative stuff. Okay, now I'm feeling okay with it. Now it looks okay. Cool. Doable? I heard it, maybe not a serious answer, but I didn't catch what it was either. I didn't even hear you, so you're good. All right. Cool. I think you need a little bit of practice. No, that's how you're going to get practice. But I appreciate the thought. All right, we're going to try something different here. I want you and your table groups to decide on the same numbers, okay? Okay. This homework, we're going to try something wonky. Haven't done this with you guys this year, but we'll see how it goes. Okay, so let's check it out. Today, that's going to drive me crazy. Cool, today is the 28th of October. We just did lesson 2.6.2, sketching rational functions. You guys, tonight, I want you to do homework 2.6. Yeah, we'll just call it homework 2.6. That was a weird pause. And here we go. Page 177. Don't make me regret it, okay? You'll see. Pick 3 problems from 17 through 40. Decide with your group so we don't have, the possibility of 36 different things to check. Here's my advice. I'm not going to tell you you can't, but I'll tell you it will burn you if you elect to do only the 3 easiest problems. If that's what you want to do, I'm cool with it. Totally good with it. But I bet that when we get to the test, it's not the easiest problems because there's testing a lot of stuff here. Cool.